Hello, welcome to another tutorial by Longhorn Physics. Today we want to talk about Ohm's law. So here's a practice problem. Here's a toaster with a resistance of 10 ohms and it's plugged into an outlet with 120 volts. How much current does the toaster draw? So in order to do this problem, we will use what's called Ohm's law. And the equation states that V, which is the voltage, is equal to the current times the resistance. So we got a toaster here. Very good toaster. There's a piece of toast there. And we have 10 ohms of resistance and we have a voltage of 120 volts. So we want to know how much current is drawn by the toaster. So in all our tutorials, we like to first go over the units and the terminology associated with the equation. So let's do that. Okay, so before we do our calculation, let's go over the equation and make sure we have the units down and see the working definitions for current, voltage, and resistance. Feel free to stop the video and take notes if you need to. So we got another way of rewriting B equals I times R is to write I as V over R. So we have our current. The symbol for current is capital I, and the units for current are amps, and they use capital, or amperes, capital A is used for that. For voltage, we have the symbol V, and the units are volts, capital V, and then for resistance, we use a capital R, and the symbol is the Greek letter omega. And here's our terminology and some working definitions for current, voltage, and resistance. Alrighty, so back to our practice problem. And before we just try and calculate, I'd like to always have a method for collecting data, organizing it, and then finally doing the final calculation. So I like to use what's called the circle label method. And what you do is you basically retype the problem here, and you circle anything that has a unit, and you try and match it with the letter in the equation. So here we go, toaster with resistance of 10 ohms. So if you know that ohms is resistance, it's easy to label it with that. So that's why it's important to know your symbols and units before you take on a problem. Next we see 120 volts. We circle that, and we know volts goes with voltage. And then how much current. So current is I, and we know that's going to be in amps or amperes. So we've organized our data or collected our data. So the next step in the problem is to put the information to the equation and use algebra. But what I found very useful for my students in my classroom is to use a math triangle whenever possible. And Ohm's law fits perfectly into that. Here's what I mean. Any equation that has the form A equals B times C fits perfectly into what we call one of these math triangles. So the letter A goes here, and the bottom letters are B and C. Does it matter where they go? Yes. Your variable that's isolated by itself in the equation will always go on top of the triangle, and the other two will go on the bottom in any order. So now we know we can use a math triangle. All we got to do is substitute the letters for A, B, and C. So in this case it would be V, I, and R. What's nice about the math triangle is it's easy to see the arithmetic once you plug in the values. So here we go. So for voltage we have 120, so we substitute 120. For resistance we have 10 ohms. And now the way the math triangle works, if you're looking for one of the corners of the triangle on the bottom, you divide these. You do have to always divide the top by the bottom. And if I were looking for V, I would multiply the two variables or symbols on the bottom of the triangle. So students can see very easily the arithmetic there. So I is equal to 120 divided by 10, so that gives us 12 ohms.